In this video we're going to do a challenge problem to practice the sums from the previous video with an arithmetic sequence. Well, this is not quite an arithmetic sequence or series. Series, remember, is the pluses, sequence is just commas. So how do we solve this problem? If you look at it, it looks kind of like a mess. What's even the pattern? So 4, 5, 7, 8, 10, 11, 13, 14. It seems like we're skipping some numbers. Okay, so there's going to be two ways to do this. So first of all, you might want to pause it and try it yourself. So the first method will be pretty straightforward using sums. So if you notice, there is a pattern. We go two numbers, we skip one. We go two numbers, we skip one. So this almost looks like those sums, but not quite, because here we're moving by 1, then by 2, by 1, then by 2. So how do we do this? So all we're going to do is separate this into two separate series. So let's do this one. And then we'll do the 5, 8, 11, 14 separately. So if you notice, this weird series is composed of these two normal series, which we know how to do. So how do we sum 4 plus 7 plus 10 plus 13? Let's use the distance method from the previous video. So the sum of every pair. So notice, first of all, 4 is one more than a multiple of 3. So is 7, so is 10. 51 is also a multiple of 3, 52. So in other words, the 52 goes with this first group, and 53 goes with the second group. Alright, so what's the sum of every pair? The sum of every pair in this first series, which I'll just write out here, is going to be 56. And now we just need to find the number of pairs. So what's the distance from 4 to 52? It's 48. Now we're moving in step sizes of 3. So 48 in steps of 3 is 16 steps. 48 divided by 3. Now 16, that's steps, so the number of numbers is one more, so it's 17. So there's 17 over 2 pairs because there's 17 numbers. Alright, now we're going to do the same thing here. The sum of every pair, if we group all the terms, will be 58. And the number of, well, we could redo this again, find the distance method, do the distance method again, or we can just notice everything here is shifted by 1. So there's the same number of numbers, same number of pairs here as there are here. So let's not redo our work, we'll just copy this over. Alright, so if you add this calculation plus this calculation, you will get the answer. We can even go ahead and do that. So, but we're not going to do that. So that's one method. Now the second method is we can add in numbers to complete this to make it easier. So let's say this is not missing. Alright, so we're going to take the original problem and add in these numbers. So now what we have are consecutive numbers, 4, 5, 6, 7, 8, 9 to everything. So from 4 through 54, what's that sum? So again, before we go with the strategies, now we're going to add in this weird thing to complete this process, and then we're going to subtract it back out. So we're basically working backwards. So from 4 to 54, that sum is 58. So the sum of every pair is 58. And how many pairs are there? Well, from 4 to 54 is going to be 54 minus 4 plus 1, if you remember the counting video. So that's 51 numbers. Not 50 numbers, but 51 numbers. So 51 over 2 pairs. So this represents the sum of all of this. Now we have to subtract off what we just added in, which is going to be 6 plus 54, which is 60. So that's the sum of every pair, times the number of pairs here, and let's use the distance method. So we're traveling 48 units. 48 units in step size of 3, 16 steps, plus 1, 17 over 2, so that's 17. How many pairs? 17 divided by 2. This looks like a little more work, but this is just to give you guys an idea of, we could either split this into two series, as in the first method, or we can add in this to make it very easy but then we have to compensate by subtracting what we just added in. So those are the two methods to do this challenge problem.